Hi, this is Leetcode question. Maximize the minimum powered city. This is the last question of Biweekly Contest number 95. So you are given an array of power stations that are distributed among cities. So in this example, city 0 has one power station, city 1 has two power stations, city 2 has 4 power stations, and city 3 has 5 power stations, city 4 has 0 power stations. Every city can give power to a city which is at distance r, in this case r equal 1. So city 1 can give power to city 1 itself, and city 0, since city 0 is at distance less than or at distance equal to r. Also city 2 is at distance r, and that means the power station at city 1 can give power to city 1 itself, city 2 and city 0. Another example is city 4. City 4 can give power to city 4 and city 3, because city 3 is at distance equal to r, which is 4 minus 3, which equal 1, and that's r. Now if we calculate the power of each city, we need to return the maximum possible minimum power of city. So we need to calculate the power at each city. So for city 0, it takes power from city 0 and city at distance r, which is city 1, and so the power at city 0 is 1 plus 2, which equal 3. The power for city 1 is so city 1 can take power from city 1 itself, from city 0, and from city 2, and the summation of the power in these cities is 1 plus 2 plus 4, which is 7. So the power at city 2 is at city 1 is 7. For city 2 can take power from city 1, city 2 and city 3. Summation of the power in these cities is 2 plus 4 6 plus 5 11. For city 3, it can take power from city 2, city 3, city 4, and 4 plus 5 is 9, plus 0 is 9. For city 4, the power at this city is, it can take power from city 3 and city 4, and the power is 5 plus 4, which equal 5 plus 0, which equal 5. And the minimum among all of these value 3, 7, 9, 11, 5 is 3. But we are given another value k here, 4, which is 4 power stations we can build on the same city, or we can distribute them among different cities so that we increase the minimum value. So we need to return the maximum possible minimum. For example, if we distribute the 4 power stations by building 3 power stations at city 1 here, so instead of 2 we'll have 5, and 1 power station at city 3, so 1 plus 5 is 6. So we used 3 at city 1 and 1 at city 3. Now if we calculate the power at every city, So power city 0 is take power from 0 and 1, so 1 plus 5 is 6. City 1 takes power from 1, 0, 1, 2, so 1 plus 5, 6 plus 4 is 10. City 2 takes power from 1 and 3 and 2, 5 plus 4, 9, plus 6, 15. City 3 takes power from 2, 3, 4, 4, so 4 plus 4 plus 6 is 10, plus 0 is 10. City 4 takes power from City 3 and 4, so 6 plus 0 is 6. And the minimum among these power is 6, so this is the maximum we can get, and this is the answer of this example. Now, how we can solve this problem? First of all, we need to an efficient way to calculate the power at each city, and to do that we will use sliding window. And to do that, first of all, we will calculate for city 0. So the power of city 0 is 1 plus 2, which is 3. 0, 3. So this is our window, and we need to move this window when we get to this index. So at this index 1, the window become like this, and so we need to add this value to our previous result. And if there is a city here before this one, like here, we need to decrement or subtract it from the previous value. This is why here we have if I minus r minus 1 is greater than or equal to 0, and here if we do subtract, and if I plus r less than n, we do we add I plus r to the previous value. So for city 1 here, I minus r, I is 1, minus 1 is 0, minus 1 is not greater than or equal 0, so we skip it. 1 plus r, 1 plus 1 is 2, is less than n. That means we need to add this to the previous value. So 4 plus 3 is 7 for city 1. For city 2, we move the window to this, so we need to subtract this value here and add the value for this city. So 7 minus 1 is 6, plus 5 is 11, so the power at city 2 is 11, and this is correct, because if you do 2 plus 4 is 6, plus 5 is 11. Now we move the window to the next index, and that means we need to subtract this value and add this value. So 11 minus 2 is 9, plus 0 is 9, so at index 3 is 9. Next we need to move the window, so the window will be here. This is out of the range, so we need only to subtract the value, this one, at this index. So 9 minus 4 is 9 minus 4 is 5, so for 4 it's 5. And we'll use the same algorithm in our code to calculate the power at every city. Now the idea to fix this problem is we need to do binary search over some range, which will have time complexity log of the max of what we see here to find this number. And for every number we will consider it as the minimum or the maximum possible minimum, and we need to see if it's possible by giving these two conditions that this number is can be the maximum possible minimum. If it can, we assign it to our answer, and we look to a greater number that can achieve this condition. If we cannot, that will be our final answer. For example, here if we are searching for the values from 0 and assume our max value is 14, so we set the left value to 0, the right value to 14 equals 0, which is left, right equal 14. As you can see here in the code, we have L right and we have M, which represent the middle. We start with M equal L plus R divided by 2, 0 plus 14 divided by 2 equal 7. So this is the first value we need to check. So here we calculate the middle. So we need to see if it's possible to have 7 as maximum possible minimum power, and to do that we will iterate over the array. So for city 0, the power at this city is 1 plus 2. We used for in sliding window 1 plus 2 equal 3. So here we need to calculate the window sum for the first index, which is this, which represent the power at index 0. 1 plus 2 is 3. Then we will use sliding window to calculate the power at every city, and if the city power is less than what the value we are checking, which is 7, we will use more or we will build power stations from K. So here 0, the value is 3, and that means we need 4 power stations to reach 7. So we will build these 4 power stations at the value 0 plus R here, and we do that to cover the city 0. So if we build it at this city as latest as possible, we can cover city 0, and it's possible we take advantage of building the power stations here that other cities in this range can take advantage of this. But for example, if city 2 needs power stations, so power city 1 can give power to city 2, but if we build our power stations at city 0, city 0 cannot give power to city 2. So as we said, city 0 has 3 power station and it needs 4, so we will build 4 power station at city 0 plus 1, which is city 1. So what we need to do is add 4 to this city, become 6 power stations, and city 0 now has 3 plus 6, which equal 9. So 9 is greater than 7, which is good. Then we move to city 1 using sliding window. We know that the power at city 1 is 3 plus 6, 9 plus 4. 9 plus 4 is 13, which is greater than 7. At city 2, using sliding window, the power at city 2 is 4 plus 6, 10 plus 5 is 15, and it's greater than 7. At city 3, 4 plus 5, 9 plus 0, 9, which is greater than 7, so this is good. At city 4, we have 0 plus 5 equal 5, and 5 is less than 7. And remember, we used, or we built all the power station at city 1, so k now is 0, no more available or remaining power station to build. So city 4 power is 5, which is less than 7, and that means 7 is not the maximum possible minimum power. So what we need to do is to search for number less than 7. In that case, we set the right value to 7. So L remains 0 and R become 7. This is the number we tested. Then the middle equal plus left plus right divided by 2 equal to 3. So we need to check if 3 can be a solution for our array. So we reset back the array. So the array has 1, 2, 4, 5, 0 again, and we have 4 power stations available. City 0 has the value 3, or power equal to 3, and the 3, so we said we need to check for equal 3. 3 is greater than or equal 3, so this is good. For 1, we have 1 plus 2, 3 plus 4, 7, so it's greater than 3. For 4, we use sliding window, and the power is at this city is 2 plus 4 plus 5, which is greater than 3. At city 3, also 4 plus 5 plus 0 greater than 3. At city 4 is 5 plus 0, which is greater. So we set, so equal 3. We were able to get proper distribution of power stations, so that all the cities has power greater than 3. So we set our answer to the value 3. Now we need to check if there is greater value greater than 3 that can be our answer. And so to do that, we set M or L equal 3 and R equal 7, and the middle value will be 3 plus 7 divided by 2, which is 5. So we need to see if 5 can be the maximum possible minimum. So city 0 has power 3. 3 is less than 5, so we need to build 5 minus 3 equal 2 more power stations from 4. So we built 2, we use 2, and 2 remains, and we will build these 2 not on city 0, we will build it in city 0 plus r, which is city 1. So city 1 become 2 plus 2, it has 4 power stations, and the power of 0 become 1 plus 4, which is 5, and 5 is greater than or equal to 5, so the power in this city is good. At city 1 we have 1 plus 4, 5 plus 4, 9, greater than 5. At city 2, 4 plus 4, 8 plus 5, greater than 5. At city 3, 4 plus 5 is 9, plus 0 is greater than 5. At city 4, 5 plus 0 is 5, and it's greater than or equal to 5, so this is good. And so we update our answer from 3 to 5 because this is greater than 5, and we keep looking for a better answer. And to do that we will set this, the left to this middle, so L equal 5, right space 7, and so M equal 6. We need to check for the value 6, so we reset our array again. So M equal 6, we need to check for this. For city 0 we have 1 plus 2, 3, so 3 is less than 6, and so we need 6 minus 3 equal 3 power stations, so we use 3 out of 4, and we build these 3 in city 0 plus r. So city 2 it has 5 power station, and the power at city 0 is 1 plus 5, which is 6. 6 is greater than or equal to 7. City 1 has power 1 plus 5, 6 plus 4, 10. 10 is greater than 6, and city 4 has 5 plus, city 2 has 5 plus 4, 9 plus 5, this is greater than 6. City 3 is 4 plus 5 plus 0, greater than 6. City 4 has 5 plus 0, which is 5, this is less than 6, and we have one remaining power station, so we build it on 4 plus 1, which is 5, but 5 is outside the array, and so we need to build it in this city. This city it has one power station, which is we used from this key, and so the power at this city is 5 plus 1 is 6, and this is greater than or equal 6, and so 6 is we update our answer to the value 6, and we look for a better solution. So L become 6, and R L equals 6, R remains 7, and M will equal 6 again, and in this case this 6 is already checked, so the previous value is the same as the current one, so we break our loop and we return the answer. So again, looking at this code, as we said here, this is the left, and r equal 1 e to the 1 to or 10 to the power 14, and that's because we have the length of the array is 10 to the power 5, and every value can be also 10 to the power 5. So we just set maximum value. We have previous, middle. We need to we use it to break our loop, and our final answer. So while left less than right, we keep looping. We calculate the middle, and we need a fresh value or array from our stations array, which is the initial values. We use sliding window by initially calculating the value for city 0, and using sliding window we will calculate we will update our window sum, and we need to check if this window sum is less than the middle, so that we use some power station at from k, and we will update the array or the city at index I plus r, and if this middle is good, we need to update our answer and looking for our greater solution. Otherwise we need to look into a solution in smaller ranges.